right, let's talk about numbers, but probably not in the way you're used to thinking about them. We're going to look at numbers not just as, well, numbers, but as tools. We're basically opening up a mathematical toolbox to see how each and every type of number was invented to solve a very specific, unique problem. I mean, have you ever really stopped to wonder why math has so many different kinds of numbers, right? Why can't we just have numbers? Why do we need fractions and decimals and negative numbers and the whole shebang? Well, here's the answer, and it's actually pretty cool. It's because every single one of those numbers is a tool. Each one was invented, literally forged, to solve a new kind of problem that we as humans ran into. And this need for number tools, it goes way, way back. I mean, look at this. What you're seeing here is a replica of a tally bone that's 22,000 years old. This shows that from our earliest days, we needed a tool to answer a really fundamental question: how many? And that basic need gave us the very first tool in our mathematical kit. Okay, so let's dive into that. Let's start with the original toolkit, the very first set of numbers created for that most basic purpose. And here they are, the natural numbers. You almost certainly know them better as the counting numbers. Simple as can be, right? 1, 2, 3, 4, and on, all the way to infinity. They are the simplest tool for the absolute simplest job, just counting stuff. So let's get our toolkit organized. We'll add the first tool to our chart, natural numbers. Simple, super effective, and as you'll see, they're the foundation for everything else to come. But, life gets complicated. Pretty quickly, what we were doing as a species became way more complex than just counting our sheep. And that meant, you guessed it, we needed a better tool. So this brings up some tricky new questions. Like, what happens when you need to represent something like a debt or a temperature that drops below freezing? How do you count something you don't have or measure something that's, well, less than nothing? All of a sudden, our simple counting numbers just aren't up to the job anymore. And so a new tool had to be invented: integers. This was a brilliant upgrade to the toolkit. It includes all the positive whole numbers we already had, but it adds all the negative whole numbers. And, this is crucial, it adds the number 0. Okay, back to our toolkit chart, let's add the new row for integers. And with just this one addition, what we can do with numbers totally explodes. Now we can handle profit and loss, temperatures above and below freezing, altitude, you name it. It was a massive leap forward. All right, so we're making progress. We can count things, we can deal with concepts like debt, but what happens when we need to start splitting things up? Breaking whole things into smaller pieces. To do that, we're going to need our next tool, rational numbers. Now, the core idea here is actually pretty simple. If you can write a number as a fraction, a ratio, then it's a rational number. And this is another huge expansion of our kit. It includes all the integers we've already talked about, plus any decimal that either comes to a neat stop or repeats in a predictable pattern. And this is where you can really see how our toolkit is growing, almost like nesting dolls. As we add rational numbers, you can see how each new category actually contains the ones that came before it. I mean, think about it. Every integer is also a rational number. You can write the number 7 as 7 over 1, right? It's a fraction. So with this tool, we can now handle recipes, precise measurements, sharing things out, all that good stuff. So our toolkit is getting pretty powerful. We can handle counting, debt, and division. But what about the numbers themselves? Are there special kinds of tools that help us understand their inner workings? Like their fundamental DNA?
Well, yes, there are. And they are the prime numbers. The best way to think of them is like the atoms of the number world. Every whole number is either a prime number itself, or it can be built by multiplying prime numbers together. They are the absolute fundamental building blocks, and they're crazy important for stuff like modern cryptography, which keeps your data safe online.
So while prime numbers give us this beautiful structure, there are other numbers that seem to totally defy it. These are the irrational numbers, kind of the rebels of the number world. You just can't pin them down as a simple fraction. Their decimals go on forever and ever without ever repeating. You've definitely met some of these before, like pi or the square root of 2. Their discovery was a huge shock to the ancient Greeks, but they are absolutely essential for things like modern geometry and engineering. Okay, so we've put together this incredible toolkit of numbers. But the more tools you have, the more you need a clear, efficient way to talk about what you're doing with them. We basically need a language for math. And that's exactly what mathematical symbols are. They're a language.
I mean, instead of writing out 19 is less than 45, you just write 19 less than 45. It's instant, it's clear, and it works everywhere in the world. It's the perfect shorthand for talking about how our number tools relate to each other.
And this brings us to a really crucial skill for anyone using this number toolkit. When you're faced with a problem in the real world, you have to choose the right tool for the job. Do you really need an exact down to the last decimal calculation? Or is a quick estimate good enough? Is this a job for a calculator, or can you just do it in your head?
Yeah, think about it for a second. If you're splitting a bill at a restaurant with friends, you probably want an exact answer, right? But if you're just trying to figure out roughly how long a road trip is going to take, an approximation is totally fine. Knowing which tool to grab and how precise you need to be is a huge part of being good with numbers.
Okay, so just when you think you've seen the whole toolkit, there's a twist, a big one. Everything we have talked about so far, from the simple counting numbers all the way to those weird irrational numbers like pi, they all belong to one giant family called the real numbers. But as it turns out, that's not the whole story. There's another kind of number out there. Numbers that mathematicians actually call imaginary numbers. And that's really the idea I want to leave you with. We've just gone on this tour of an amazing toolkit that literally built our world, from counting ancient livestock to designing modern computer circuits. But it turns out this entire real number toolkit is just one part of a much larger and way more mysterious mathematical universe. So it makes you wonder, right? What other problems are out there that require even stranger, more incredible tools to solve?